Unofficial, advent of code, day 20. Here we go. With the scanners fully deployed, you turn their attention to mapping the floor, get back from the scanners, random noise. You can clean it up a little bit. Image enhancement algorithm, normally given as a single line, wrapped multiple lines. How to enhance an image by simultaneously converting all pixels in the input image to an output image. Each pixel of the output image is determined by looking at a 3x3 square of pixels in the input image. Okay. Alg equals grouped stars 0, 0, input image. Input image, light is pound, dark is dot. Each pixel of the output image is determined by looking at a 3x3 square of pixels centered on the corresponding input image pixel. Value of 510, you look at 49, got it. A single binary number that is used as an index into the image algorithm. Got it. Input image dot map stir dot g sub puts input image. Okay. Got it. Apply the image enhancement algorithm twice. Okay. Image map equals input image dot map to x. Row. No, this is y. Row dot cars dot map dot width index. Hash dot new. Image map xy equals ch. Def iterate image alg. Okay. X's equals image dot keys. xmin, xmax, map first dot minmax last xmin time do x new image xmin if ch equals so we want to go through y map index equals join alg x plus dx or no image new image oh no equals alg index. Final image 2 iters equals iterate image map alg. How many are on? Puts 2 iters dot count. Part 1. Image map. Wait, what? Puts Puts image dot inspect. New image XY. That sounds right-ish. Nope, too high. $81. Print image XY. Puts where are those dots coming from? Oh, that's why. That's not right. Index equals index stir. Puts index at index. Oops. That's not right. Why are they all zeros? Image. Huh? That's why. That's not right. Also, why is it flipped? That's why. Dot values dot count p. $5,480. What? Too high. What? How is that wrong? That looks suspicious. That line at the top. Why does that happen? Puts okay, that's right, it seems. Okay, 5,480 is too high. 512. And what did I miss? Simultaneous converting all pixels in the input image. Zero 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 1 0 0 0 1 0. Should be a light pixel. Oh. Or that's it. Alg 0, the default is okay. First false. Or first 0, otherwise alg 0. First true. Five, 3, 6, 1. Boom, there we go. 50 times second equals iterate image map alg true. Third equals iterate second alg third times do la 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 la, almost there. What? Too high? Oh, okay. Because this thing is wrong. So the thing's one layer out. See things. so they see things. But 2 layers out don't see things. So this isn't quite right either. Because this will be fill iter 1, iter 2, iter no. Outside equals outside outside or outside. And then the new outside index equals side put CEO, thank you for the follow. Okay, perfect. Now it's alternating and it should work. 16826. Woohoo! I did it. Let's see what the leaderboard was for this one. I don't think I did very well. Nope. 18 minutes. Oh well. All right. Let's go over this one. All right, day 20, trench map. With the scanners fully deployed, you turn their attention to mapping the floor of the ocean trench. When you get back the image from the scanners, it seems to just be random noise. Perhaps you can combine an image enhancement algorithm and the input image to clean it up a little. For example, this is the input. This is a string of length 512 on one line, and then your image. First section is the image enhancement algorithm. It is normally given on a single line, but it has been wrapped to multiple lines in this example for legibility. The second section is the input image, a two-dimensional grid of light pixels and dark pixels. The image enhancement algorithm describes how to enhance an image by simultaneously converting all pixels in the input image into an output image. Each pixel of the input image is determined by looking at a 3x3 square of pixels centered on the corresponding input image pixel. So, to determine the value of the pixel at 510 in the output image, 9 pixels from the input image are needed to be considered, the 9 neighbors. 9 input pixels are combined into a single binary number that is used as an index in the image enhancement algorithm string. The string is exactly 512 characters long. The output pixel is the value in that string indexed by this number converted to decimal. And then you do it you repeat it. The images are infinite in size, and so every pixel of the infinite output image needs to be calculated exactly based on the relevant pixels of the input image. A small input image is only a small region of the actual infinite image. The rest of the input image consists of dark pixels. Cool. So this is what we get. And the question is, how many pixels are lit? First part, you iterate twice, and the question asks how many pixels are lit in the resulting image. And then part 2 is you just iterate 50 times and how many pixels are lit. So this is what we do. Get our input, break it into groups of strings. The algorithm is the first string, and we're going to replace all the pound signs with ones and all the dots with zeros. And then our input image, we're going to do the same thing. And then we're actually going to store our image as a map where everything will just be a map from index to the value. And at first, for the first iteration, it's just going to contain the ones, but that's not going to apply later. So it's pretty simple. I don't know why I say that. I mean, I just spent a half hour. Obviously, it's simple to explain the code that is written now that it's written, because it's, linear. But to actually solve it, ignore this outside variable at first. Basically, we have the image map. We iterate over it to get the second thing. We iterate over it to get the third. Part 1, we just count how many values of that thing are 1. Then for part 2, we iterate 48 more times to get the value for part 2. Outside. Yeah. So how do we iterate? So we have our image. We get all the keys, which are all the indexes. To get the min and the max, we take all the x coordinates are the first values of these keys, and then we get the min and max value. The y coordinates are the last values. Get the min max. Because the edges actually touch, basically it'll keep expanding slowly. And so one layer outside of the things that have cells, we need to consider those. So we decrement our x-mins by 1 and add 1 to our x-maxes. And then this is just printing stuff out. Cool. So we're going to create a new image. We're going to loop over every x and y, and then we're going to loop over all of the neighbors. Important to iterate over the y first, so it's in the correct order, and then the x. And then we look up the value of that image or this outside thing. That's basically what is contained on the outside. So when you start, the outside is these dots, which are zeros. So we build up a string of that, and then convert it to an integer in base 2, and then we look up that index in the algorithm and set our new image value. So then the interesting thing that we have to consider is that on every other iteration, so all these are zeros, but we actually run this algorithm on everything. And so if all of these, if the 0 value in your input algorithm is a £, everything outside of your image will actually convert to a £, which is not the case in the input example. But then on the next iteration, everything that's a £, is a 1. And so they might then convert back to a 0. Or then you have to look up index 511. And you'll find that input 0 is a £, and 511 is a dot, whereas it's the reverse there, or it doesn't matter what this one is for the example, because these never convert to £. So we have to keep track of like what the outside looks like. So the outside starts as 0, and then at the end, after we've built up our new map, we basically take our outside, build up a string of 9 things like it, convert that to an integer in decimal, and then look up that outside index in our algorithm to get what the new value on the outside is. And so you'll notice that in the example, it's just always 0, but in my input, it actually switches back and forth, which is why my solution was wrong at first. So yeah, that's it. That is Advent of Code 2021, day 20.